Hi students. In this lecture, I am going to discuss problems. Let us see first one. See the question given. An open tank 5 meters long and 2 meter deep is filled up to 1.5 meter height of oil of a specific gravity 0.7. The tank is uniformly accelerated along its length from rest to a speed of 20 meters per second horizontally. The shortest time in which the speed may be attained without spilling any oil is. So condition is here, shortest time without spilling any oil. Okay, let us see how to start. So first see the question given. Dimensions are, so it is given now a vessel given length equal to 5 meter, 5 meter, 2 meter deep. This total value given to 2 meter deep. So filled with oil up to a height of 1.5, up to a height of 1.5 with oil. So it is now having acceleration horizontally, acceleration horizontally. Now condition is that it has to attain velocity 20 meter per second in shortest time. And condition is oil should not spill outside. Okay, let us see how to solve these kind of problems. So first focus a vessel which filled with a liquid like this. So when it is at rest, when vessel is at rest, free surface will be horizontal. Okay. When there is no acceleration, I'm drawing once again here. When vessel is stationary, free surface will be horizontal. Now, when it accelerates, when it accelerates, free surface cannot be horizontal. Now see how shape becomes. When it accelerates, shape becomes now, it becomes inclined, and that will be like this. It becomes inclined like this. If acceleration is right side. Okay. Now we have to focus. What is the angle made by this free surface with a horizontal? Okay. Let us see how to start. So vessel is now accelerating horizontally. Free surface will be inclined. We want to calculate now angle of inclination with the horizontal. This angle is now theta. Acceleration is. Let us solve the question from the vessel frame. That means imagine you are sitting on the vessel. Now it is a non-inertial frame because vessel is having acceleration. Okay. Now let us focus one a particle on surface. Let us focus one particle on the surface. Forces that are acting on that element. One is mg, vertical downwards. It is its mass dm into g. mg downwards. Since acceleration is now right side and we are solving with respect to vessel, we have to take pseudo force, that is dm into a. It is dm into a. Now you can see resultant of these two forces must be normal to this free surface, because since the liquid is at rest, with respect to him, liquid is now at rest. It is in equilibrium. When there is no liquid flow, net force must be normal to free surface, because if there is any force parallel to free surface, then liquid flows. I am repeating. If there is any force along the free surface, then liquid flows. But condition is now it is at rest. It is a static condition. So whenever liquid is at rest in static condition, net force will be normal to free surface. Therefore, resultant of these two will be normal to free surface. That means this is angle theta means this also same angle. You can see here. This is normal to horizontal. This is normal to this free surface. Therefore, between the normal same angle, right? Now question is just like this is one vector and this is one more vector. This is now resultant of those two vectors. Then angle made by the resultant with one of the vectors, that is given by, you can see tan theta, that is equal to opposite by adjacent side. Opposite means take parallel to this dm into a. dm into a, this is now dm into g. That means it is equal to a by g. See carefully. I have taken tan theta. Okay. It is a by g. So angle made by the free surface with a horizontal is tan inverse a by g. Okay. And now focus here one more point. If you imagine a layer which is parallel to, so I'm imagining one layer which is parallel to free surface, which is parallel to free surface. This is now free surface. I'm taking one layer which is parallel to free surface. Now, at each and every point in this layer, at each and every point in this layer, pressure will be same. So if you are taking at any point in this plane, just imagine a plane that is a parallel to free surface. At each and every point in this plane, pressure will be same. Okay. Suppose if you take here, let us say no acceleration. No acceleration means free surface will be horizontal. So if you take any layer parallel to that, at each and every point, pressure will be same. Okay. Now here also same logic. If you are taking a layer which is a parallel to free surface, then at each and every point, pressure will be same. Okay. Or you can take, for example, I'm taking a depth y. Suppose this separation, I'm taking a line vertical along vertical. If this is y, if you take any vertical line from here to here, this is also y. That means depth from here it is y. We have learned that pressure will be same at same depth. Okay. If the sea is y, this length equal to y. This length also y. Okay. Same depth. All these points are at same depth. See carefully. From here, distance y, distance y, distance y. All points are at same depth. Depth means we measure from the surface. So from here y, from here y, same depth, same pressure. But remember, these points are not at same level. See meaning of same level. We can see here, these points are at same level. We can see these points are at same level. Okay. Here, it is also same depth, same depth, same level in this case. But coming to here, same depth, depth is the same, but level is not same. If you take now, they are now at different levels. This is now at this level. This is at this level. This is at this level. So same level, different from same depth. So here, same depth, same level. All are at same level. Depth also same. Coming to here, all are at same depth, but all are not at same level. Level is changing. This point is now at this level. This point is now at this level. So level is changing, but depth is the same. Okay, so that we have to keep in mind. Next, in this case, see how we are calculating pressure. If you want to calculate pressure, suppose we are taking a layer which is parallel to free surface. Between these two, separation equal to h. Okay, separation equal to h between these two. In that case, pressure in this layer is equal to, it is equal to P naught plus rho g if the C is equal to h. Wait, this is rho g. It is rho. In the place of g, we are writing square root of g square plus a square into h. See carefully. Between these two layers, distance equal to h. Okay. Then pressure now in that layer is equal to P naught plus rho in the place of G, square root of G square plus A square into H. This is just like G effect too. If you remember, we have solved many questions like this. Acceleration is horizontal, mg downwards, angle is 90. We are taking now G effect too. That's what is square root of G square plus A square. So P naught plus rho square root of G square plus A square into H. Okay. Next. And let us see one more point here. Just imagine one cylinder inside. So physically there is no cylinder inside. We are just imagining one cylinder. So we are just imagining a cylinder like this. Suppose length equal to L. And let us take this is now at a depth h1 and this is now at a depth h2. Okay, acceleration is now here. Now see what we can write. The cylinder is now having acceleration a right side because This entire vessel is having acceleration here. That means the liquid in the vessel also having acceleration here, right? That means this cylinder is also having acceleration here. That is right side. See how much force acting on this face. Okay. Because net force on this is equal to, it is right side. So I'm writing here net force on that. And on this face, force equal to P1 into A. That is right side. On this face of force, it is P2 into A. So minus P2 into A. This is now net force. Net force equal to mass into acceleration. Mass is length into area, volume, into density. That is mass into A. So M into A, right? So in the place of P1 minus P2, first I can cancel here A, both sides. Cancel A, both sides. P1 minus P2. P1, H1 rho g. P2, H2 rho g. So it is now H1 minus H2. That is equal to P1 minus P2 into rho g. So P1 minus P2 into rho g. That is equal to L rho A. Okay. Or you can see here relation tan theta equal to A by G. If you see carefully here, this triangle, this is angle theta, tan equal to. This is now H1 minus H2. So tan equal to H1 minus H2 by L. So H1 minus H2 by L. That is equal to tan. Here, rho gets cancelled, rho and rho gets cancelled. H1 minus H2 upon L, that is equal to tan. Tan equal to A by G. So we got same thing. Okay. Next. So here this is the pressure P1 and this is now P2. So relation between P1 and P2. See how we're writing that. Relation between P1 and P2. P1 and P2. That we are writing as P1 minus P2. That is equal to H1 minus H2 into rho g. Right. Now see what we got here. H1 minus H2 into G is equal to L into A. It is equal to, in the place of H1 minus H2. H1 minus H2 into G. H1 minus H2 into G. Write L into A. So it becomes now L rho A. So in terms of H1, H2 relation, P1 minus P2 equal to. In terms of length of the cylinder and acceleration, L rho A. Okay. So these points we have to remember regarding the vessel accelerates horizontal. So free surface makes some angle with horizontal. That is given by tan theta equal to A by G. Right. And next, any layer that is a parallel to free surface. At each and every point in that surface, pressure will be same. And that value how much? Between the layers, if separation equal to H, P naught plus rho into square root of G square plus A square into H. Next, P1 minus P2 in terms of H1, H2, in terms of L and A. Okay. So these points we have to keep in mind. Now focus the problem given. So coming to here, length given, depth is given, filled up to 1.5 meter, specific gravity, it is not required for us, accelerates. So from rest, okay. So we have to get velocity 20 meter per second velocity, shortest time in which it may be attained without spilling any oil. Right, use now the results which we got. Right. So vessel, so filled up to a height. This is given 5 meter, filled up to 1.5, 1.5, total value 2. So if it accelerates right side, if it accelerates right side, condition is that not spilling. Not spilling means, so initially level was like this. Okay. Not spilling means now the level can become, it can become like this. In fact, we have to make this diagram properly. So it is, this has to pass through the midpoint of this line. Okay. So we should draw through midpoint. It is through midpoint. So it can rise remaining half meter. This is a half. This also half. Okay. That is what we can say from diagram 0.5. That means directly from this diagram, we can write what is the angle made by the free surface with a horizontal. See how much it is. So tan theta is equal to, so this is a half and this is a half. So this total value how much? This is 1, right? So it is 1. And this length equal to 5. 1 upon 5. That is now tan theta. And that is equal to A by G, right? And if you take G value 10, A value will be 2 meter per second square. Sorry, second square. That means if acceleration is more than 2 meter per second square, what happens is this liquid now it spills outside. Okay. So limiting case is 2. When it is a 2, it is about to spill, not spilling, about to spill. Okay. Right. And once we are getting acceleration, initial velocity is 0. Finally, we have to get 20 meter per second. Since acceleration is a constant, we can write v equal to u plus 8. This is now 20. U value 0. A value 2. And this is now t. Okay. Now in this, A value maximum 2. Remember, this is maximum. Why maximum means? Because if it crosses 2, it spills. So A value maximum. When this is maximum, this will be minimum. Okay. That means minimum time, or you can say shortest time. That is not 20 by 2. It is at 10 seconds. Okay. Right. Let us see the next problem. See the question given. A narrow tube completely filled with liquid is lying on a series of cylinders as shown. Condition given that it is a completely filled, means up to here, okay? Completely filled. Assume no sliding between any surface. The value of acceleration A of the cylinders for which liquid will not come out of the tube from anywhere is given by. Condition is that liquid should not come outside either in this way or in this way, right? So this is based on a rolling motion. We can see if acceleration of the cylinder center of mass is A. Okay. Condition is no sliding, means no slipping. If ACM is A, then for topmost point, ACM plus R alpha, right? That means for the cylinder, sorry, for this tube, acceleration is now 2A, right? Let us see. So when we are keeping a tube, condition is that liquid is not coming out any from anywhere, either here or from here. It should not come outside. This is now placed on a series of cylinders. When acceleration is A, for the tube, acceleration will be 2A. The relation is that no sliding. That means for topmost point, what happens? Acceleration will be ACM plus R alpha, right? And in this case, we are knowing that for bottommost point, ACM is equal to R alpha, rolling without slipping. Therefore, this is equal to 2 ACM. That means for that tube, acceleration is 2A, right? Now, question is just like there is a tube, L-shaped tube. It has acceleration 2A. Now, condition is liquid should not come outside, either from here or from here. Okay. Then see what we can write. Now I am focusing the horizontal part of the tube. Okay, only this part. So when I am focusing horizontal part of the tube, horizontal part of the tube, that means focus now only this part of the liquid. This is now shape of the liquid. We are knowing that liquid takes the shape of the container. So this is now liquid, okay, which is present in the horizontal part. Forces that are acting on this liquid. Forces that are acting on this part of liquid. By this part of liquid, force acting on this face. See how much? That will be P naught plus P naught plus. See what is now this height. It is given L shaped. This is L and this is L. P naught plus. It is L rho G. That is now pressure. Okay. Into this cross section area. Right. Into that cross section area. Then we get a force acting on this face. Right. Now focus carefully here. Force acting on this face, it is equal to P naught into A, right? Because liquid is not coming outside. Pressure is now that of atmosphere, right? Okay. Now see carefully. Net value P naught A gets cancelled. Remaining is now L rho G into A. This is net force. Net force equal to mass into acceleration. Mass of this part of the liquid. Mass equal to A into L. Just cross check once. What is that length given? Is it L or H? Let me cross check once. See the question once, the notation given there. Right. I have taken notation wrong here. Let me correct it. This height is given L. Okay. This is L. Height equal to H. Height equal to H. This is H rho g. This is given L and this is given H. Okay. Right. So this is net force. Net force equal to mass into acceleration. Mass equal to this cross section area into length, that is volume, into density, that is mass into acceleration. Acceleration is now 2a. It is not a. Now see calculation part. Rho cancels. A cancels. H and G, right? That is left. So we have to find here H value. So H equal to, it is now 2AL upon G, right? But here what we have to calculate? We have to calculate acceleration at not H, because H is given, right? In that case, acceleration is A equal to GH upon 2L. That is acceleration, right? So condition is that it is not coming outside. So we can take as a whole. So for this part, net force how much? Net force equal to mass into acceleration. Then we get the answer. This is now linked with rolling motion. There is a chance of writing this acceleration is A. That is wrong. Because it is acceleration for what? For the center of mass of the cylinder, means for the axis. But coming to here, it is now 2A, right? That means answer is, it is option B, right? It is GH by 2L, right?